remember that in order to determine if a job is going to be late or not, you have to first determine its flow time, or when it will actually be finished. That is the task at hand in this particular problem. Let's take a look. Consider the following 3 jobs. Okay, job alpha requires 2 weeks of work and is due in 4 weeks. Job beta requires 3 weeks of work and is done in 5. Job Carlos requires 1 week of work and is due in 3 weeks. Okay, so this is just classic single work center job shop scheduling data. What's the question? If these jobs are completed in alphabetical order, how late will job beta be? Okay, so the key to this particular problem is that we've gotten all this job scheduling data verbally, and we're asked if one particular job is going to be late. What we actually have to do first is we have to create the sequence. Okay, well, to create the sequence we need a rule. Oh, wait a minute, I underlined that. They said completed in alphabetical order. That's going to be the rule. All right, that means that alpha will go first, and then beta, B, will go second, and then Carlos, C, will go third. Now, oh, the question's about beta. Is beta going to be late? But in order to determine the tardiness of beta, you always have to determine flow time first. So I'm going to sneak in a column here for flow time. That is to say, when will each of these jobs be finished, so that I can then figure out tardiness. That'll be the column next to it. All right, now, flow time first. Okay, flow time, you begin with the first job. The first job is called alpha. Alpha, look up the duration. Requires 2 weeks of work. Alpha is going to be done first, so the flow time of the first job is its duration. The flow time's 2 weeks. It'll be finished in 2 weeks. Beta, I need to look up the duration. Beta requires 3 weeks worth of work. Okay, so the flow time on the job called beta is 2 weeks. Wait a minute, that's the 2 from the row above, plus the 3, that's its own duration, or 5. The job called beta will be finished in 5 weeks. Why? Because it has to wait 2 weeks, that's the 2, right, while alpha's being finished, and then it's 3 weeks of work. Okay, now actually at this point, if you're really alert, you may realize that we don't need to complete this table, and that there's also Carlos down here. You know, what is the flow time of the job called Carlos? I'm going to do it anyway, just for the sake of demonstration. Carlos, let's see, Carlos will wait 5 weeks, the flow time of the job before, plus I look up the duration for Carlos, 1 week. So the flow time for the job called Carlos is 6 weeks. It'll be done in 6 weeks. Okay, now, the question was about lateness. That means we need to calculate the tardiness next. How do you calculate tardiness? You compare the flow time, now that we've calculated it, with the actual due dates. Okay, so alpha. Alpha will be finished in 2 weeks. I need to look up the deadline on alpha is due in 4 weeks. All right, will be finished in 2 weeks, is due in 4 weeks. It's not going to be late. This is just logic. Therefore, the tardiness is 0. Nothing. It's not going to be late. Beta. Okay, beta requires 3 weeks of work. Wait a minute, we already used that, and is due in 5 weeks. That's the promise for the job called beta. We compare that to the flow time when it will actually be finished. Oh, it looks like it will be finished right on time. It will be finished in 5 weeks, just in time. That's still a tardiness of 0. Oh, and that is the answer to the question, because that's what the question asked. Beta will not be late. It'll actually be right on time, but to answer the question, how late will it be? It won't be late. Now, just for I hate this blank right here, let's also complete the tardiness for Carlos. Carlos is 6 weeks worth of, or Carlos will be finished in 6 weeks. Carlos is due in 3 weeks. Carlos is due in 3 weeks. Will be finished in 6. There's going to be some tardiness. 6, when it will be done, minus 3, when we promised, reveals that for the job called Carlos, it'll actually be 3 weeks late. Nonetheless, it asked about the job called beta. We could have quit there, and that we just discovered is not going to be late. If you look at the next problem, you'll notice it's about the same 3 jobs. Alpha requiring 2 weeks of work and due in 4 weeks, Beta 3 weeks of work in 5 weeks, Carlos 1 week of work and due in 3 weeks. That's the same 3 jobs as up here. Okay, now must be a different question. If the jobs are sequenced in shortest processing time, SPT is shortest processing time, how late will the job called beta be? Oh, so in a certain sense the question's the same in that it's asking about that same job beta, and it's asking if it will be late, but what's different here is the sequence. It says, but if they sequence the whole set of work in terms of shortest processing time, we need to go through the same steps. The first step is establish what that sequence would be. Oh, okay. If you're using SPT, shortest processing time, then what you do is you check how long each job requires for processing, 2 for alpha, 3 for beta, and Carlos requires 1, and you schedule the smallest one first. Shortest processing time. Okay, so with this particular sequence, the job called Carlos would be first because it's the shortest. Then you look for who's the next shortest. Okay, that'd be alpha. All right, so here's the difference. In this sequence, that job called beta would be pushed to the back. Oh, all right, fine. Now what? Same steps. We can't determine how late it will be until we determine the flow time first. So I'm setting up a column for that. Then we can determine the so-called tardiness by comparing the flow time to what was promised. All right, flow time. The flow time of the first job, in this case Carlos, is its processing time. Okay, Carlos won first place because Carlos is only 1 week worth of work, therefore it'll be done in 1 week. Alpha is 2 weeks worth of work, so alpha's flow time is 1, the flow time of the job before, plus 2, its own duration. 3, alpha will be done in 3 weeks. We need that because that means beta will wait for 3 weeks. Beta is 3 weeks worth of work. So the flow time for the job called beta is 6 weeks. Beta will be finished in 6 weeks. All right, now tardiness. Oh, at this point we could just do the tardiness calculation for beta. We don't actually need to fill in these 2 rows right here. I'm going to do that just because I like complete tables. So I'm just curious, is Carlos, for instance, going to be late? Okay, well, Carlos will be finished in 1 week. Now you check the due dates. Is due in 3? It's due in 3, it will be finished in 1. Nope, not tardy. Okay, alpha will be finished in 3, but what did we promise? Alpha is due in 4. Oh, alpha, not going to be tardy. Beta, and that's actually what we were after, will be finished in 6 weeks. Beta is due in 5 weeks. 6, when we will actually get done, minus 5, what we promised, reveals a tardiness of 1 week. So to answer the question, and that's really all that we needed again, beta will be 1 week late if you follow the shortest processing time sequence.